Hello, welcome back. In this video, we're going to take a look at the second part of the Gravitational Forces Gizmo Lab. That is Activity B, Gravity and Distance. What we want to know is, how does distance affect the strength of gravitational force? Well, the first thing we're going to do is we're going to want to turn on the Show Distance feature, and we're going to want to set mass A and mass B to 10 kilograms. Okay, or 10, it's 10 times 10 to the 5, but the prefix of the number is 10. Okay, that's the first thing we want to do. So let's go to the lab. The default, each mass, as you can see, is already set to 10. We're going to click on the top center box that says Show Distance. You can see right now the distance is 40 meters as a default. The hypothesis is asking you to think about, how do you think the distance between object A will affect the strength of gravitational force? And then leading on to that more specifically, number 2, how do you think the gravitational force between two objects will change if the distance is doubled? So the prediction is kind of a more specific add-on to the hypothesis. Everybody go ahead and pause the video, complete your hypothesis, complete your prediction, to kind of take a guess at what you think is going to happen with those, the relationship between those variables, and then we'll go ahead and actually measure and take some data in just a moment. Okay, now that you're back, now that you've had a chance to make your hypothesis and prediction, let's go ahead and actually measure. What we're going to do is we're going to place object A on the x-axis at -5 and object B at the x-axis at 5. It might even be helpful to put Show Grid, which is the upper right-hand box. There we go. And what I'm going to do is I'm going to move object A, I'm going to slide it over to 5. And I'm going to move B, I'm going to slide it over to 5. Sorry, A is at -5. B has been slid over to 5. Okay, so now let's go ahead and address some of the measurements so we can see what it is we're actually going to take data on. So part 3 is all about understanding the measurements. What is the distance between the two objects? Well, the distance between 5 and -5 would be 10 meters. And so you can see when the object is placed at 5 and -5, it has a distance of 10 meters. Well, how do we get the magnitude of the force on A again? Let's take a look. All we have to do is turn on the box in the lower right-hand corner that says Show Vector Notation. And you can see the amount of force applied on A is 0.667 newtons. .667 newtons. Now that also goes here as well. The only difference is you don't need to write in the units because the units of newtons are already handled right here. This is going to be our force factor of 1. Now what that means is this is our original baseline calculation. What we're going to do, guys and ladies, is we're going to double distances, triple distances, quadruple distances. We're going to change the distances, and we're going to see how much bigger or smaller does the force get. If the force gets bigger than 1, then the force increased. If you get a force factor that's less than 1, then you know the force decreased. Let's take a look at how this looks. In the next one, we're going to move the mass A to -10 and mass B to 10. And we're going to repeat. A to -10, B to 10. You can clearly see that the distance is 20 meters between them. Showing vector notation for this. There we go. Okay. Show vector notation. And again, let me put object A, show connecting a line. Okay, A to -10, B to 10. And we can see the force vector, the force on A is 0.1667 newtons when there's the double the distance between them. So the distance between -10 and 10 is 20 meters between them. And the force was reduced from 0.667 to 1.667. We'll talk about the calculations for this in a minute. Let's continue taking data. Now we're going to triple the distance for each one. And we're going to go, the distance between 15 and -15 would be 30. And the distance between -20 and 20 would be 40. So let's take a look at these two data points. At -15 and 15, you can see the force vector reduces itself, the amount of force on mass A, reduces itself to 0.0741 newtons. And again, that feature is located at the very bottom left corner of the screen. Let's copy that down. 0.0741 newtons. Now let's move each one back. To -20 and 20. And you can see the force, the amount of force on A has reduced itself even more to 0.0417. Okay, now we can do a little bit of math. How does this compare to this? Well, here's what we're going to do. We're going to take this value here and we're going to divide it by each of these values to get the respective force factors. So let's do the first one. 0.0667, divide that by 0.1667, and we get a force factor of about 4.0011. We'll just say a force factor of 4. Okay. I'm sorry, ladies and gentlemen, I have this backwards. We want to take the new force value and divide it by the original force value. I'm sorry, I have that backwards. 0.1667 divided by 0.667. So we're going to take this divided by this, and we get 0.25. We get a quarter. So by doubling the distance, the force has reduced itself by 4. It's gone down by 4. Okay, now let's take a look at this. Now we're going to take this number, 0.0741, and divide it by the original force. So 0.0741 divided by 0.667, we get about 0.111. Okay, and in parentheses, I'm going to put what these are. So this is 1/4. This is actually 1/9. 1 divided by 9 is 0.111. Okay, and then lastly, if we take this value here, 0.0417, and divide it by the original force, we get 0.0625. Okay, now 0.0625 is 1/16. Now, what does this mean? It means if I've doubled my distance, my force factor has reduced by 4. Well, there's a connection there. If I've tripled my distance, to go from 10 to 30, you're tripling your distance, my force is reduced down to 1/9. If I quadruple my distance, my force has now been reduced to 1/16 of its original value. Let me write these in again. Now, what we're going to do is we're going to take 1 over the distance squared. Here's how we do that. The distance is 10, 20, 30, 40. So, first one, we're going to square all those things. So 10 squared is 100. So 1 over 100, divide that, and we get 0.01. The units for this would be square meters. Okay, but we're taking 1 over 100. In this one, we're taking 1 over 400. 20 squared is 400. And we're taking 1 over that. So 0.0025. For this next one, we're taking 1 over 900. So this is 1 over 400. This is 1 over 900. .00111. And the last one, we're taking 1 over 1600, which is about 0.000625. Now, if you notice something here, guys, if you notice something about this, the digits are all off by 2 decimal points. Each answer is off by 2 decimal points. Well, that means it's off by a factor of 100. Okay, what does this mean? It means, guys, that as distance increases, the force is going, if distance increases, the force is going to decrease. As the distance gets farther apart, the gravitational force is going to get weaker. Okay, so here's what I want you to try. Okay, part 6, well, we kind of did that. We kind of did that already. So here's what I want you all to try. I want you to attempt 7, 8, 9, 10, and 11, the best of your ability, and we will talk about this next class.